When it comes to volume of solids, we're basically going to look at three different types of solids, and there's really only basically three formulas you want to look at. The first type that we're going to look at is going to be when it's the same two-dimensional object stacked on top of itself a bunch of times to create your three-dimensional object. One example of that is a rectangular solid. So the basic picture of a rectangular solid is we have some sort of rectangle and it's three-dimensional. The base of this is a rectangle. And if you thought about that like a super thinly sliced rectangle, there's a bunch of those stacked on top of each other. Basically, you could think about it like a piece of paper. A piece of paper we can think about as having the area of that piece of paper, but if we stack a whole bunch of them on top of each other, then that's going to create some volume. So in this case, our piece of paper is 8 inches by 7 inches, but we have it stacked 3/4 of an inch tall. So the area of the piece of paper would be 7 times 8. But once I stack a whole bunch, I'm going to multiply that one into the mix. And that's going to be my volume. So if your three-dimensional object is basically the same shape stacked on top of itself a bunch of times, then you can take the area of the base and multiply that by how high it is. And that's really what we've done here. So if we grab our calculator and do this multiplication, we have 7 times 8 times 8 times 3/4. That's going to be 42 in this case. And when it comes to our unit of measure then, we had inches times inches times inches. That gets us cubic inches. A cylinder is another example of one shape stacked on top of itself a bunch of times. So in this case, we've got a soup can. Soup can looks something like this. And you can think about this like a whole bunch of circles being stacked on top of each other. If you took a quarter and stacked it a whole bunch of quarters up, you're going to get a cylinder. So we can again say the volume is going to be the area of the base times the height. Now in this case, the base is a circle. So that's pi r squared. And then the height. So in this case, our radius was 1.7. So we have pi times 1.7 squared. And then our height is 5.3. And so we get a calculator out to handle that multiplication, where we have pi times 1.7 squared times 5.3. And we're going to get 48.12. And it was inches times inches times inches, so this is cubic inches. I had mentioned that there were three different types of volumes we were going to look at, where we have a shape stacked on top of itself a bunch of times. And the second one then is when we have a shape that could almost be stacked on top of itself, but it comes to a point. And so they're progressively smaller versions of the shape. So as an example, a cone. A cone comes to a point. Anytime we have one of these 3D shapes that come to a point, we're going to take the volume formula that we had before of taking the area of the base times the height, but we'll multiply by 1/3. Because we can fit 3 of those into the shape of a cylinder in this case. So once we have that formula, the area of the base in this case was pi r squared because it's a circle. We know the diameter is 28, which means the radius is going to be 14. The radius is half that. So we have 1/3 times pi times 14 squared, and then our height is 11. And once we have that, we can toss this into the calculator. We have 1/3 pi times 14 squared times 11. And we get 2257.8. This time our units were feet times feet times feet, and so we're looking at cubic feet. Now a pyramid's another example of something that comes to a point. And so in this case, we're looking at a stone pyramid in Egypt that's got a square base that measures 140 meters on each side with a height of 90 meters. And so if we're looking at our formula again for volume, we could say, well, let's look at the area of the base. Let's multiply that by the height, but because this comes to a point, we need that factor of 1/3 out in front. Now in this case, the area of the base, well, it's a square base, so we're going to take our side squared times the height. Our sides were 140 meters each, and the height was 90 meters. Oops, 90. And now we can grab our calculator and plug that in and see what comes up. So we got 1/3 times 140 squared times 90. And it looks like it's 588,000. In this case, it was meters times meters times meters. So we're looking at cubic meters. I had mentioned there's three basic kinds of shapes, where we have some sort of two-dimensional object stacked on top of itself a bunch of times, or a two-dimensional object stacked on top of itself that comes to a point. The third thing is the sphere, the ball. In this case, I'm going to tell you just to straight up memorize the formula. The volume for a sphere is 4/3 pi r cubed. Now again, take a look at the power of r. For circumference, it was 2 pi r. For area, it was pi r squared. And for volume, it's 4/3 pi r cubed. Notice that circumference is being raised to the first power, and you're measuring something that's one-dimensional. You're measuring something in feet, inches, yards, meters. When it comes to area, your radius is squared. And you're measuring something that's in square inches, square feet, square meters, which is area. And when it comes to volume, you have r cubed in the formula. And you're measuring something that comes out in cubic inches, cubic feet, cubic meters. So pay attention to that power of r's. It's really going to help you to differentiate between these formulas. Now in this case, we are given that the diameter was 10, which means the radius is half that, it's 5. And so once we know the formula that applies and what the radius is, we toss those numbers in and we can grab the calculator out and finish this problem out. With 4/3 times pi times 5 cubed. And we end up with 523.6. In this case, it was centimeters times centimeters times centimeters. So it's cubic centimeters. Now let's talk about combined shapes or composite shapes. Just like when we were dealing with the area of composite shapes, we're going to try to find what are the two shapes involved, or sometimes three shapes. Let's find their volumes independently and then add them together. So in this case that we have this snow cone, our two shapes involved are we have the cone part and we have half a sphere. So we just have the top half of a sphere. We had just covered that the volume of a sphere is typically 4/3 pi r cubed. But in this example, we have half of a sphere. So we're going to multiply that by a half. Now for a cone, the base of a cone is a circle. So the area of that is pi r squared. And we have height. And it's one of the volumes that comes to a point. So he's going to have a factor of 1/3 in him. So the cone is 1/3 pi. Our radius is 5.8. So we have 5.8 squared. And the height is 7. Now as far as the half of a sphere, 4 divided by 2 is 2. So we have 2/3 pi. And then our radius is 5.8 cubed. So if we want to save our kind of steps in the calculator, we could write this all out together that the full volume is going to be 1/3 pi times 5.8 squared times 7 plus 2/3 times pi times 5.8 cubed. And we could put that all in one step if we really wanted to. So we can say 1/3 pi times 5.8 squared times 7 plus 2/3 pi times 5.8 cubed. Now, one of the nice things about putting it all together in one step is if you make a mistake, you can go back and fix that mistake. I'm going to jot down this number first, 655.2. And this was in cubic centimeters. But if I want to go back and fix it, I can arrow back up and hit enter in case I had made a mistake somewhere and said, oh, I need to fix something. I can arrow over to it and fix wherever it is that I made a mistake. And then hit enter again without having to retype a whole bunch of stuff.